Hello friends, in this video we are going to see how to use a package. In the previous video we saw how to create a package, and if you remember we organized three classes in two packages. Now we will use those classes which is defined inside a package, or simply we will see how to use a package. So once we finish with this video tutorial, then we will resume back to our inheritance which we stopped before. Yeah. So on the right hand side, have a look at the three classes which is organized under two packages. If you see C.2d, C.3d, which is defined inside math.points package. C.2d is a class and C.3d also a class. So there are two classes under points package. Inside the util package we have one class called circle. So we saw this in the previous demo. So we created these two packages and three classes, and we haven't defined that in the previous video. If class circle wants to access C.2d, it can use a fully qualified name including the package. Just like how we specify a fully qualified path for our file name, we can specify a fully qualified path to our class. Say for example, the fully qualified path for C.3d is math.points.c.3d. Similarly for circle, math.utils.circle. Right side you can see how we create C.2d inside any class. So here if you see math.points.c.2d, so that defines the type. C.2d is the type, the end target, but which is contained inside the points, and the points is subpackage of points is a subpackage of math. So math is the main package here. Points is a subpackage. Inside points is a package. We defined the class called C.2d. So this is what called the fully qualified path or fully qualified name to our class. Point 1 is the reference name. Then we used the new keyword to create the class C.2d. Importing packages. So in the previous example you saw that you can create any class within a package by using that fully qualified name. So if there are many classes that you are going to use in your class, then specifying that fully qualified package name will create trouble in program readability. So your complete code looks like this fully qualified class names, and which looks clumsy when you are looking at the code. So importing packages comes into picture to avoid such a situation. To avoid fully qualified name, Java provided importing the packages. So just like #include statement in C++, here you can import the package. In C# we use the using statement for a namespace. So the same way in Java we provide importing the packages. For example, to import C.2d and circle into your implementation class, the following imports can be written. The imports look like this. Import math.points.c.2d. That means the C.2d is imported to your implementation class. That means inside the class you can create a C.2d. 2 d, 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 2 d in the phone file itself. Say for example, instead of using the fully qualified name, you can now write c.2d point 1 equal to new c.2d. Same goes to circle as well. We can import all classes in a package using the asterisk at the end. Say for example, in the previous statement, method.points, instead of c.2d, you can place a star. That means all classes defined inside the points package is available to you. That means c.2d as well as c.3d both are available to you once you place a asterisk. But Java doesn't recommend placing the asterisk and importing all the classes inside your package. This is to avoid a name collision. So the statement is here, import math.points.star. That means we are importing all the package, all the classes inside points package. And points is a subpackage of math. So let us define our point2d class. Previously we saw how to create a package and place a class inside a package. Now here the first line is math.points. So in the next line we started creating our class point2d. That means here point2d belongs to maths. So in point2d we defined two member x and y. Then we have two constructor. One is a default constructor which initializes x and y as 5 and 10. Then in the overloaded constructor we receive two parameters so that we can initialize these members from user provided value. Then there is a method called print which prints the coordinate value x and y. So to recap, first we placed the package keyword, then we gave name to the package method.points, then we defined our class point2d. So now point2d belongs to points package. Next we defined point3d class, and if you see here also the first line of statement is package method.points. So previously we placed point2d in method.points. Here point3d also belongs to method.points. Then we defined our class the same way we defined the point2d. Here we have a 3 coordinate value x, y, z as members. Then we have two constructor. One is the default one which runs from 9 to 14. Then we have a overloaded constructor point2d which initializes the value xyz, the internal member xyz with a user's applied value. Then we have a print method that prints the coordinate values. Here we are defining the circle class inside the util package. So that's why the method.util is a first line, and hence the circle which we define from line 7 to 24 belongs to util package. And at line 5, if you see, we imported a package math.points.point2d. That means we now need to specify math.points.point2d inside our circle class. That means we no need to specify the fully qualified name. Instead, we can directly specify point2d. You can see that at line 10. So the circle class has a primitive type radius, which is at line 9. This is a primitive type. At line 10, we need a class to specify the origin. So we used point2d, but point2d does not belongs to util package. It belongs to a different package called points. Even though the math is the main package for both utils and points, since point2d is defined in points, we already imported that at line 5. Since it got already imported, here we are directly using point2d origin as a member at line 10. So point 2D is referred here, and we don't need to specify the fully qualified path name. Circle uses point 2D as member. Yes, you saw that in line number 10. So this also is circle is defined in the package method.util. Why? Because that's the very first line. Line number 2 specifies package method.util. So whatever class we define after this belongs to the util package. Here we define circle class, and hence it is the member of util package. So in the constructor, we are once again referring the c.2d org, then int radius. Based on these two incoming parameters, we are initializing the internal member. Here the circle does not have any default constructor. It has only one constructor that has up two parameters. The first parameter is point2d and second one is int r. You can see how we are avoiding the fully qualified path name by making use of the import keyword. Here we are just using only one class. Imagine if a class refers multiple classes from different package, then specifying the fully qualified name for the class inside your new class is makes the code not readable. Right, so finally we have a print method that prints the origin of the circle using origin.print. Then we print the radius using the system.outprint. If you see, since origin is an instance of type point2d, we are accessing its member function print here. The print is defined as public in the point2d class. So it is available here in the print method. So here is our program main entry. So in the program we want to use circle as well as point2d. Here we are just creating the circle and we want to print the circle detail, but circle depends on point2d. So we imported point2d at line 2 as well as circle at line 3. So first at line number 9 we create a point2d instance. So this point we will use as origin of circle. So x and y denotes 4, 4. So this 4, 4 denotes a point, and we are going to use this point as origin of the circle. Next, we create the circle instance at line 12. Circle C equal to new circle of org, 7. So org is created at line number 9. So that is point2d. We are passing that to the circle's constructor. Then we are passing 7 as a radius. So with this constructor itself, we can say that we are creating a circle of radius 7 with an origin 4, 4. That means x coordinate is 4 and y coordinate is 4. And radius of circle is 7. Once the instance is created, it is stored in a reference C. Then we are making call to c.print. Since print is a public, we are accessing it here in a class called package demo. So c.print will print the circle's detail in the console output window. Alright, let us explore this in Eclipse. So here is our point2d class. Since we already have the class, I am just copying the implementation detail. In the last video we saw that we have two packages. First we will define our C.2d. So previously we created it as a C.2d. Now I'm changing the class name to .2d. So Eclipse recommends change the compilation unit. That means the file name to .2d to match with the class name. See here, the file name is a C.2d here. Once I click here, file name will get changed. Let us save this. So we already saw about this class, two member, one constructor, default constructor, then overloaded constructor, then a print method which prints the x and y coordinate values. Next, C.2d. If you see, the members are private, but the method we kept as a public so that we can access these member methods anywhere. All right, let me copy this. So instead of typing, I am just a copy paste. I'm doing the copy paste so that we can save some time. C.3d. Here there are three internal members, one constructor, default, and one overloaded constructor, and then a print method. Let me save this, then I will change the class name. So this error is sorted out now. Then we will go to our circle class. So I'm not copying this particular import statement. We will do that later. If you see here, we are getting error on .2d. Wherever it has a .2d, we are getting the error. So once we use that import statement, the error will go away. Or I can click here, and if you see, import .2d from math points. So if I click here, Java will automatically place that line for us, and it will resolve that issue. So once I click save, you can see the issue get resolved. So next we need a package demo.java. So I'm creating a new class. Since we need a public static void main, I am placing a check mark here. This is our program entry point. This package demo class is our program entry point. Since I already have that in clipboard, I'm just deleting the content completely. So now we will debug and see how it works. Alright, now we are staying at this particular line number 9. So I'm stepping inside. This is class loader. Let us do step return, then step in again to get inside our constructor. If you see here, we entered into the constructor, and this point2d is defined under the maths package, math.points package. So we are creating the instance. Now origin is ready, holding the value of internal members x and y with the value of 4, 4. That's what we passed here. Next, we are creating the instance of a circle. Here if you see, the origin is already initialized, and this import statement resolves this point2d type. Here we are initializing the internal member origin. That means we are holding the reference. So the org holds the reference. Now we are handing over that reference to the internal member origin. Then radius we are setting it as 7. That's what we passed when we are constructing this. Here if you see 7, that also get initialized. So if I expand circle, you can see there are two members. One is origin and another one is radius. There are two members. Radius is initialized to 7. But origin is actually a reference referred by ID 42. So if I click expand this, you can see the content of it. Also you can see org is also 42. Both are pointing to same. Arch in this package demo is pointing to some heap location at identified by the ID 42. The circle member origin also pointing to that same location. So the ID proves that both points to the same location. Next, so if I expand, you can see it's the same 4, 4. This is also 4, 4, because when we expand, we are just reading the content from the heap location identified by the ID 42. Here also, if we expand, we do the same thing. The name may be different. Here it is origin, internal member. Here it is org at a package demo level. But both are pointing to the location 42. And there the content is 4, 4. All right, let's print the circle. This is C. So if you see, we entered inside the member function circle. The access is public, and we are going to print the content of the circle. First we print origin of the circle is that get printed in the console output window. Then we are making use of the print method of point2d. So it prints the x coordinate as 4 and y coordinate as 4. So origin of the circle is 4, 4. Then we print the radius, so which is coming from the circle itself. So that's all in this demo. So the point you have to note here is, if you want to use a class from a package, we can do import. So at the starting of the, so you can place it anywhere, the import statement. But when you are defining the package, that should be the very first line. So the import, as per the coding standard, import should be also at the top of the file. But you can place anywhere. There is no restriction in it. But follow the standard. First define the package name like this. then there should be import. After that, your class definition. All right. Once again, this is how we define our package. Then whatever class we keep after that belongs to that particular package. So there should be only one package in a file. Then this is how we can import a package. Here circle use point2d, so we imported it. Our main class uses both point2d and circle, so we placed two import statement. So we can put star also here instead of point2d to import both point2d and point3d, but Java does not recommend that. That's all in this video tutorial. Thanks for watching. If you like the video, subscribe the channel by clicking the subscribe button below the video. Thanks again for watching. Bye.